Okay guys, thanks for joining me. Today we're going to look at this Husqvarna AutoMower 430X. It has a slight issue with the back motor. Let me see if I can stand it up. I'll see if I can show you. This is the good one. And you can see it's a little bit wobbly. But this other side, number one, it's angled, and you can see right here it actually is shattered and broken. And so I don't know what happened. Maybe it fell into a hole, and but it's getting a little bit old. So we're going to disassemble this and see what I need to do about this. Probably a new motor assembly, but I may be able to 3D print just this frame, because the wheel is actually working really well. It's just angled outward, and therefore the whole mower is a little bit too close to the ground. So first and foremost, we have to get under here and switch off the power. If you see right here, we turn it over. So first we want to switch off the power. Make sure the power's off before we do anything. Now, in order to get this lid off, you just pull straight up gently on each corner, and I'll show you. Once these four corners pop loose, this whole upper deck just comes right off. There is a wire on the front, so you want to be careful to keep that front. There are two wires actually on the front, and we want to just flop it over that way. Now it's a bit dirty, so we'll kind of clean it off a bit. But then we will have to probably take all those bolts around the perimeter and take the shell open. So let's do that. Okay, so just do a little cleaning here and try to get each of these screws exposed. So these four screws around each of these, we probably don't want to remove. But all just the perimeter screws around the whole shell. So this is a good trick on something very dirty like this. Get a screwdriver, or this is a little Allen key, much smaller than the screw you're trying to clean out. And you can just get in there and dig around and get that dirt out of there. And that'll get those, because each of those is going to have to be relatively clean. These are all Torx bolts, Torx screws into the plastic. So we do need to clean them out a little bit so that that Torx bit can get in there. The other thing that's very helpful is a vacuum cleaner. Let me get my vacuum cleaner going. We have gotten it reasonably clean, and I think it is important to get it reasonably clean before we open the shell, because there's an O-ring that goes all the way around, and we don't want to get too much dirt in there, because that's the waterproofing, and we do want to kind of maintain the waterproofing as much as we can. So we have 1, 2, 3, 4, 5, maybe 6, I think 12, maybe 14 bolts to undo, and then that whole shell will come off. So let's do that. This is a Torx bit, so let me get my Torx bit. Okay, so this is a Torx 10. That is too small, but I can use it to clean that screw out. This is a Torx 15. Still a little wiggle. I think it's a Torx 20. So just wiggle it around, see, get some of that dirt out of there. This is now a Torx 20. Yeah, Torx 20 seems like the right one. So we'll just undo all these screws around the perimeter. And I do have some Torx bits I can put on power, so might as well put it on power in order to extract those. But putting them back in with power would be, I think, dangerous, but we can extract them with power. kind of keep them in order as I go. Okay, I think that's all of them. Let's see. I think I still have to get these two up here. So now the shell is coming off. And again, there's wires connecting to the shell, so be careful of that. Let's bring the shell over here. And we're looking specifically at this motor wheel. We're going to see if we can figure out how to get that off. And we will, I think, have to take, I don't see any attachment from this side. I hope. Well, we would have had to get in here to disconnect these anyway, but let's figure it out. So I'm going to turn it on its side. Just stand it up like this. And we will want to get this bolt off, this nut off the wheel, and take off the wheel. Okay, and I do have a socket wrench that's big enough. This looks like a 24 millimeter socket wrench for this. So we've got our nut, and there is a washer, metal washer, and then the wheel will come off, and you can see 3 little holes. Actually, it's just the little ridges. The little ridges catch that wheel, so we can set that wheel aside. And you can see one of these screws was actually already had worked its way loose. So I think we should remove the other 3 though, and the entire motor should come out, and then we can take a closer look. But this whole assembly, see, is jiggling and broken. So let's take out, I think we can take out this one other screw, and that whole motor will fall out. And this screw's already loose as well. And I think that will let that entire motor come out anyway, right there. So you can see here, the wires are zip tied. So I'm just going to undo that zip tie and undo that spin tie there. Let's just undo this one. And those wires can come out of there. And I believe it's this. I believe it's these small wires. I don't think it's that. I think it's this is the motor plug right here. There is on the back side, you have to pinch in order to let it unlock, and then gently wiggle. Okay, that should be the motor wire we need to get out. And then I will have to undo the zip tie here just to let it get loose. Okay, so I'm going to very carefully snip this zip tie without cutting the wires themselves. And so we can redo that zip tie later or not, I'm not sure. And here we are free, and that's the only wire that goes to the motor. So we should be able to remove the entire assembly. And that motor, I think, can work its way all the way out. And again, there's nothing wrong with this motor. There's nothing wrong with that. I just need the plastic mount. So maybe there's a way to fix that plastic mount. We'll have to take a closer look. Okay, so just cleaning it up a little bit and trying to see what's happening here. It is I think this is a planetary gearbox inside here, so it's a gear reduction motor. So as this motor moves fast, that's a gearbox right through here that makes it roll very, very slowly here. Now we do have, and what we might need to do is to run that motor in order to get it to line up so that we can get the screws out of this little plastic casing, because I think I want to imitate this plastic casing and 3D print something to replace that plastic casing. So what we can't do is force this, because the gearbox won't support us spinning that around. Potentially we'll have to remove here in order to get that to work, but I think if we could just manually rotate this That might be the way to line up those. Line up, and there's probably bolts that if I can get them to line up, we can get them out of there. I might be looking at one of them right there. Okay, as I'm messing with this motor assembly, I did notice that you can rotate it by force. So I think what we need to do is just rotate it to the point where we align it with the screw holes. And then, yeah, I see a screw right there. And I think I can rotate it so it lines up with those. But worst case scenario, I can buy this entire motor unit. Should cost me $160, I think, to buy this entire unit. I was just hoping to be able to actually 3D print the solution because it's only the bracket. The motor still works fine. But I don't know if there's a way to get this off of here. Okay, so we've got all 4 screws loose, and you can see I can pry this back. Okay, so I did go ahead and order an entire new motor drive assembly. That is right here. And so it's already pre-done. But I am realizing that I ordered one that is, looks like it's smaller. It is a different motor. It is not necessarily for this AutoMower. It does have the same connector. The wires appear to have different colors. But it's the exact same connector there. There was really no way to know. So I'm gonna have to do a little research here on whether this is capable of doing the job. Okay, so I accidentally ordered the wrong motor. It's a slightly smaller motor. I don't know if it will work or not, but the colors of the plug are different. So I'm a little bit nervous about that. So what I'm gonna do is try to use a gear puller. This is called a gear puller, gear bearing puller. And what we basically will do is try to pull the tip of the shaft off, and then I can get the plastic off, and we can basically, maybe I can 3D print a replacement for that. So let's see how it goes here. I'm gonna first I think I have to loosen this, open this up, open up these jaws, let these jaws open up. I'll show you how this works. These are pretty cheap tools. I think this cost me 20 bucks or something like that, but I've had this for a long time. Use this for some other projects. So the first step will be to put this nut back on here. This is just a normal wheel nut, so we can have something to grab onto. I'm going to put that here, and we're going to try to clamp these outer jaws just lightly around there, but it'll catch that nut. And as soon as those are kind of lightly on there, then I think I'll be able to push with the center. I'll be able to push this thing off there. So it doesn't have to be super snug on there because it is going to catch this nut. And as I screw this down, it'll start going down in this shaft, and it will pull this, in theory, off of here. I might need to put a spacer in there to try to get it to do this, and I might need a little more leverage on this. Okay. And let's see, is it making progress? Is it coming off of there? And I don't want to rotate the motor, but this is rotating from the claws and pushing the shaft out. And it is making some progress. But I'm getting bottomed out on these threads, so I will have to undo this and put something down into that little hole, some little chunk of plastic, metal probably, that I can push on to continue the process. So for right now, I'm just going to undo this, and I'm going to find something to put down into that in order to push further. Okay, so I backed out the screw quite a bit, and I just have a bit. It's like a large hex bit. It should be just enough to give me some leverage there and continue to push on that shaft. So let me get that engaged. Try to center that up pretty good. And I think now we're continuing to push, and it slid off the side. Okay, so what I have is a large screw. I'm going to put that down in there, and I think that'll do the job. It also has a hex center, so it should stay centered up in there. Let's see, yeah. So I'll line that up, and just line it up to get it started on this little pin, center pin. And I think that should continue to do it. Let's do it. Yeah, I think that's working. And you can see we're making progress pulling that shaft off of there. We have to be careful because once this is loose enough, this whole motor, I think, will fall off of there. So I do have to kind of catch that. Okay, here we go. And that's it. So basically the gear puller pulled on the outer part while pushing the shaft down the middle, and so now it's off of there. So it's a little dirty, but I can get all this out of here, and then I could take those 4 screws and we'll kind of duplicate this part, I think, on the 3D printer, try to replicate that and make a replacement. Okay, more to come. Okay, so I've already loosened some of these screws. We're going to basically take all 4 of these screws out. Okay, 4 screws are out. There is an O-ring, so I should try to imitate that on my design, but otherwise 4 holes with an inset for the motor to sit in. We'll probably clean this off, grease this a little bit, maybe oil this back end down the front end, and then imitate this part on the 3D printer. The O-ring is pretty critical. The 4-bolt pattern and the inset there is pretty critical. The distance from this surface to that surface and this surface to where the motor sits, the bolts, is critical. But everything else is just kind of decorative. So I'll just imitate this kind of outer ring, and we'll try to do that. So this should be a very cheap part to reproduce. I'll probably create it on and then sell it to you guys on my Etsy page. I'll put a link to that too. And I will have to remove these other 2 in order to have the entire broken piece so I can imitate it. Okay, so there's the entire piece. I can kind of loosely put that back together and then regenerate something like that on the 3D printer. I wonder, this little notch is probably something. Yeah, I'll probably have to notch it for that. I can probably make these walls thicker in order to make it stronger. I can probably fill in some of this with material to make it all stronger. Because this is injection molded plastic, so it's going to be stronger than what I can 3D print, but I'll make some of these surfaces thicker. And we'll try to reproduce that. Okay, so here's our Fusion 360 design. You can see this is the inside. This is where the O-ring goes. And you can see 4-bolt pattern to attach the motor and 4-bolt pattern to catch on the mower. If we flip it around, this is the outside. There is a little ring, I guess, to keep the water out of it. And again, the bolts go all the way through. We send it to the printer. There is mostly support. There's the object. So here's my design. I'm going to just take the whole plate off. And then we have some support. Had to do some support. But the smooth side is the O-ring side. So let's test our O-ring first. Yeah, it looks pretty good for the O-ring size. Looks pretty close. Okay, have our piece here. I'll peel off the support there. I might have to use something to shove that support off. There we go. That support came off pretty nicely. So it's really pretty rough on that side, but it should be functional. And then we wanted it nice and smooth by the O-ring. So this is the other motor assembly. So far looking pretty good. The measurements seem pretty good. I cheated and made it a little thicker on the outside, and then O-ring goes in there, so just try to attach our motor. So the motor can go through. And does it line up with the screw holes? Pretty good. Screw holes are lining up pretty nicely there. And we'll try to attach the motor with these screws. I purposely made these screws just a little bit, these screw holes just a little bit snug. So these are a little snug. I'm threading them into the plastic, but that will basically make it perfect. There it goes. This one's having a little trouble getting it to actually get into the middle. Okay, I swapped 2 of the screws here, so hopefully. Okay, I think I finally got it to go. I'll just retighten my other 3. And I did, when I 3D printed this, I did 3D print it with just solid. There's no infill at all. It's, I think, 99 walls or something. So, okay, so I've got that here. And let's see if I can get this to fully seat on here. See if this will sit down flush. On these injection molded parts, they always leave a little bit of plastic out, but when I 3D print, I print it solid because it's not quite as strong, so they've got a lot of gaps. And that's right where the O-ring, I think, will get pressed onto there. Let's see if this will line up and fit on there. Yeah, it looks like it's gonna go on there. It is snug, but that's how we want it. Let's try to put these screws on, and I would have to remove it again in order to put the wheel nut on there. And these are Torx. So far so good here. Now if this fits nicely, which I think it will, I will remove this again because I do want to, I'm gonna have to use a hammer to push on that wheel nut, and I don't want to hammer it into here because that would hammer it and break my mount, my bracket. But it seems like that's fitting on there nicely, and I think that's a pretty good fit. And we'll basically use a hammer and tap that into there, but I don't want to do it here. I want to have the back end supported against probably the cement floor. But this is looking good, I think. Got a good part here as a bracket, and I'll be able to get this lawnmower back up and running. So take this back off. I think that sits approximately as far in as the previous does. Let's get it back out of there, and we're going to just use a hammer. We've got to support the back end on the cement. We're going to support the back end on the cement and then give it some light taps to put this back into place. And that should be good.
This is a concept called an interference fit. So on the left side, we have the wheel adapter with the hole in the middle of the wheel adapter. On the right side, we have the motor shaft. This is being viewed in cross-section as if we cut it all in half. There is a slight overlap here where the motor shaft is slightly larger than the hole in the wheel adapter. So as we insert it, the motor shaft has to get a little bit smaller and the wheel adapter has to get a little bit larger. So the metal of the motor shaft is getting slightly compressed and the metal of the wheel adapter is getting slightly larger, and then the friction between the two is what keeps that in place. Again, that's called an interference fit.
Shove to the bottom of it there, kind of support that a little bit, and we're just going to lightly tap this. This should put this back in place. And you can see it's lining up almost. And I think that's pretty good. I think it was just slightly proud there from the bracket. And my bracket is on there nicely. Okay, we're going to put it back in the mower. Don't want to over tighten these into the plastic because these could strip out. Look pretty good. That looks pretty solid. Let's put the wheel back on. So, nut off. Okay, so I'm going to use an impact driver to try to spin this off of here. There we go. That got it off of there. So in hindsight, when I hammered on that, I should have put a socket over there to hammer on the flange, not on the actual part near the threads. So we should be okay. Now, we will put our wheel. And I've got a washer. And I will tighten this by hand. We don't want to use an impact driver to tighten this on here, but I might need to just gently do it just beyond the little stuck part here. Very carefully. And that seems the maximum torque of this is not that much. It's just a inch pounds, not foot pounds. Let me just double check it with yeah, I think it's on there good. Now I've got a decorative piece that can go back on there to cover all that, and we're ready to lay it flat. This up here for a minute. I am going to vacuum out any dirt I can get out of there. And don't forget to plug in the motor before I button it up. And that goes right here. I could do a test before I bolt it together, actually, and just see if it will operate. So I think I will do that. Just lightly put this back on. Okay, a super quick test before I bolt it all back together. It's just kind of sitting on there, ready to go. Okay, close hatch. And it's moving, so that's sufficient. That's a good enough test to bolt it all together. So it was rolling, and it was rolling straight. Okay, we've got it back in the shop. Just have to take the lid off. I did power it down. We'll gently put that off to the front. And we just have to put all our bolts back in around the perimeter here. And these are Torx 20. Okay, all ready to go. Put the lid back on. Gently snap those all back in. And now we can use the handle to carry it. Okay, final test. Gonna turn it on. Ready for pin code. And now it's ready, so I can start. Close the lid. And there it goes. I would say it's gonna mow, but I think it's actually gonna have to go straight to the charger here and charge up before it does much mowing. And there it goes, it's heading for the charging base. Okay, guys and girls, thanks for joining me. A little bit of a roller coaster ride to get that fixed, but we're back in action. So I'll have to send that other motor back. But thank you so much for watching. Don't forget to hit like and subscribe and share this channel with your friends.